Hello and welcome back to another lesson in pre-calculus. Today, we're going to be continuing our conversation about rational functions. So far, we have determined ways to find all of the asymptotes of a rational function. And today, we're going to be able to graph rational functions by hand by finding all of the characteristics of the rational function, which includes finding the asymptotes. And our do now here, we're going to find all of the asymptotes of this function. Now, we have we have a possibility of a vertical asymptote, the possibility of a horizontal asymptote, and we have the possibility of a slant asymptote. Now, let's first look at the degrees of my numerator and the degree of my denominator. Because they are both 2, we are not going to have a slant asymptote. That's because a slant asymptote only occurs when the degree of my numerator is exactly 1 bigger than the degree of my denominator. So we will not have a slant asymptote. So now we're only looking at vertical asymptotes and horizontal asymptotes. Because my degree in my numerator is the same as the degree of my denominator, our rule says that we are going to divide the leading coefficients to find the horizontal asymptote. The leading coefficient on top is 1, and the leading coefficient on the bottom is also 1. So we're going to divide 1 by 1 and get y is equal to 1 as our horizontal asymptote. Vertical asymptotes. Now, up to this point, you know to set your denominator equal to 0 because you can't have a 0 in your denominator. And that is where you would find your vertical asymptotes. There are some scenarios where you have to do a little bit more work. Here is one of those scenarios. What I'm going to do is, just for fun, I'm going to factor both the top and the bottom. And I have x minus 2 times x plus 2 on top. And on the bottom, I get x minus 2 times x minus 1. And what you'll notice is that x minus 2 and x minus 2 cancel out because I have a common factor on top and bottom. And I'm left with just the function x plus 2 over x minus 1. Up to this point, you would have thought that this factor would have given me a vertical asymptote, but it does not. The vertical asymptote only comes from this factor right here, the simplified version. So the only vertical asymptote is x equals 1. This thing right here, x minus 2, does not give you a vertical asymptote. Well, then the question is, what in the world does it give you? Like, why is it even there? And that is the question for the next slide. So in this case, we have found 2 asymptotes, 1 vertical and 1 horizontal. So what does this x minus 2 give you? It gives you something that's called a hole. A hole is just a single point removed from the function. It's just a single point removed from the function. It's not a line like an asymptote. It's a single point. Okay? How do you find holes? Well, you factor and then cancel any common factors. Okay? Now, just a reminder, this is going to be a point, because it is a hole with a single point removed, which means that the answer is going to be x comma y, because a hole is a single point removed, whereas an asymptote is a line. That's why asymptotes are equations and holes are points. So let's do this one more time. We're going to factor this like we did. X minus 2, x plus 2, over x minus 2, x minus 1. Now, when these two cancel out, we're left with x plus 2 over x minus 1. To find the whole, we set the common factor equal to 0. So this is the common factor, x minus 2. So when does x minus 2 equal 0? Well, at the value when x is 2. That means that my whole has an x value of 2. To find the y value of the point, we're going to take this 2 and we're going to substitute it in to the simplified version. Now, why the simplified version? Well, let's go back to the original function. If I was to input 2 into the original function, I would get 2 squared minus 4 over 2 squared minus 6 plus 2. This gives you 0 over 0. In mathematical terms, 0 over 0 is a sign that says do more work. 0 over 0 is not a number. It means do more work. So the more work that we're doing is we are factoring and we're simplifying. And that will happen every time there's a whole. You'll always get 0 over 0. So this is not the answer. So what we have to do is we have to input it into the simplified version. And when we do that, we get 2 plus 2 over 2 minus 1, which is 4. So we get the point 2, 4. So in this example, the whole is at 2, 4. What does that mean? It means if I was to graph this and I was to go to the point 2, 4, there would be a physical hole missing there. And I will show you. Here is the function. If I went to the point, I'll make it bigger so you guys can see. Projector mode, there we go. If I go to the point 2, I'm getting closer to 2. Once my x value hits 2, boom, there is a hole there. It's undefined. It's where the point is supposed to be, but in this function, it is just removed. Right? It is just removed. So the point is supposed to be 2, 4. All right, that's what we found out. And I'll show you here. Like the point is supposed to be right here, 2, 4. I'll even graph it for you. It's supposed to be right there, 2, 4. Right? I can fill it in, but if I don't fill it in, there's an actual hole there. You can't see it from the naked eye on the graph, but you can calculate it by factoring and simplifying. So a hole is not an asymptote. It's just a single point removed where the function is supposed to be. And you can find that hole by factoring and canceling out any common factors. What you'll notice is that I also have graphed the simplified version. When I graph the simplified version, you'll see, there we go. You'll see the simplified version is the blue version. The red version is the original function. And what you'll notice is they are the exact same function. And that is because they are equal to one another. The only difference is that this blue function doesn't have any holes. Only my original one does. So if I went to my blue guy and I went to the point 2, 4, let's get rid of this. I went to the point 2, 4, it would be there. Boom, 2, 4. There it is. But if you go to the red function, it's not there because there's a hole. So they look identical. Just that one single point is removed from this function that we're looking at. That is a hole. So we have asymptotes, and now we have holes. The next characteristic is x-intercepts. You guys know what x-intercepts are. It's where the graph intersects the x-axis. You can find this by substituting 0 into y, because every single x-intercept is a number, comma 0. Right? This is a point, the number, comma 0. So if I'm looking for the x-intercepts of this, I can either do it for this one, or I can do it for the simplified version, which we have here, which is x plus 2 over x minus 1. Because remember, they're the same graph, right? So I'm going to use the simplified version because there's less numbers. And when I set this equal to 0, in order to solve this, I'm going to multiply the top of both sides by x minus 1. So I end up with x plus 2 is equal to 0. So I end up with x is equal to negative 2. So the point that I have is negative 2, comma 0. This is the x-intercept of my graph. So we have two asymptotes, one hole, one x-intercept. The next characteristic is a y-intercept. And this is where the graph intersects the y-axis. And again, because this is a point, and it is a point where the x value is 0, we can find this by substituting 0 in for x, which means that we are just finding f of 0. And when I input 0 in for x, whether I do it in this function or in this function, because they're the same, I can find f of 0, which is 0 plus 2 over 0 minus 1. So I get negative 2. So I get a y-intercept of 0, negative 2. Okay, it is a point. Okay, so my characteristics, how do I put all of this together into a graph? Well, the first thing I want to do when I am trying to find the characteristics and graph it is I want to find any holes. That's the first thing I want to do, because if I can find holes, that means I can simplify the function. And if I can simplify the function, I want to simplify it first. There's not always going to be holes, but there could be. And if there is, I need to find them first. Once I find them, then I need to find the asymptotes. Okay, find the holes first, because a lot of students get confused when there are holes and they think they're asymptotes. Asymptotes and holes are different. Okay. Number 3, then we find the x-intercepts and the y-intercepts. And then finally, once you find all this and you plot it onto a graph, if you still don't have a good image, find any extra points that you may need. Oh, points. Okay, start inputting any x values and finding y values just to get a better idea of how the graph looks. You might not need it, but if you do, just that's the last thing you should do, is find some points. So let's put the function we have all together. Okay, we first found our asymptotes. We had 2 of them. We had x equals and we had y equals. Our horizontal asymptote was y equals 1, And let's go back and double check. And our vertical asymptote was x equals 1. Those were our two. Oh. Those were our two asymptotes. So let's graph those. I'll put them in red. Okay, so x equals 1 is a vertical asymptote that I draw a dotted line for. That looks like this. Y equals 1 is a horizontal line. That looks like this. Good. Then we have our x-intercepts. We had our x-intercept at -2, 0. And our y-intercept at 0, -2. So I'll plot those 2 points there on my graph. So I have this point right there and that point right there. And last is the hole that we found. The hole that we found was at the point 2, 4. Let's go back to here, the point 2, 4. Now this can be plotted. 2, 4, we're gonna put an open circle there because there is a hole. It's not actually part of the graph. The graph has an open circle. Open circle means it's a point removed. Now, at this point, I don't need to find any other points for this function. Here's why. I have one vertical asymptote. I have points on both sides of the vertical asymptote. I'm now going to utilize my asymptotes to help me guide the function. I know asymptotes are lines that my function gets really close to. So my function is going to be down here, be really close to this function or this line. And it's going to go through that point right there. It's going to go through that point right there. And then it's going to continue down and get very close to this line. Over here, I know it has to go right around 2, 4. And it must follow this asymptote, so it must be like this. And then it'll probably look something like this. If you wanted to, you could have found one more point in this vicinity, but you didn't have to because I just used my asymptote to guide me. And this is the rough estimate of how my graph looks. Let's compare it to Desmos. Boom, wow, that looks pretty close. Right? Look at that. Whoop. Okay. So I use my characteristics to plot them on a graph and then use the asymptotes to guide my function. Let's do another example. Here, I want to graph this without a calculator. First thing I want to do, find my holes. So if I factor this, oh no, I have a common factor. That means there is a hole in this function. When I simplify it, I'm left with 1 over x minus 1. There is a hole at the 0 of my common factor. So my common factor is x plus 1. The 0 of it is -1. Right? So it's when x plus 1 equals 0, which is -1. When I input -1 into the simplified version, I end up with 1 over -2, which is -1/2. So I have a hole at -1, -1/2, and I'm going to put an open circle there. Right there. Okay. Now, I'm looking at just this function. Asymptotes. Vertical asymptotes come when my denominator is equal to 0. So when I set x minus 1 equal to 0, I get a vertical asymptote at x equals 1. So here's x equals 1. Let's put a vertical asymptote. Okay. Then I want to find my I want to find my horizontal asymptotes if there are any. Well, the degree on top is technically 0 because it's x to the 0 power. And the degree on bottom is 1. Because my degree on top is smaller than the degree on the bottom, that means that I have a horizontal asymptote at y equals 0. So I'm going to draw that in a dotted red line, like so. I want to find my x-intercepts. My x-intercepts is when I make my y value equal to 0, which means that it would be 0. I'll do it over here. It would be 0 equals 1 over x minus 1. If I was to multiply both sides by x minus 1, I'd be left with 0 equals 1. Well, 0 never equals 1. So that means that I do not have any x-intercepts, which should make sense because I have a horizontal asymptote on the x-axis. So very rarely will you have an x-intercept if you have a horizontal asymptote. I don't want to say never because we learned in our last section that you could sometimes cross over a horizontal asymptote. The y-intercept is when I find f of 0. So finding f of 0 would be 1 over 0 minus 1, which gives me 0 comma negative 1, which is this point right here. Okay, this is all I have so far. Now, in this case, I'm going to have to find some extra points. And that's because I have 2 points on this side of the vertical asymptote. So I can draw this side because I have 2 points. It's pretty easy. It has to go through these two, and it has to follow the asymptote. So it must be something like this, and then come down, and something like this. Okay, but over here, I don't really have an idea of where it goes. So I'm going to input a value to see, to give me at least 1 point. So I'm going to input the x value of 2, because 2 is to the right of this vertical asymptote. So when I find f of 2, I get 1 over 2 minus 1. So therefore the point is 2 comma 1, which is this point right here. And now I have 1 point, and I can kind of just use my asymptotes as guides to help me from here on out. And it looks something like this. All of my characteristics plotted onto a graph. Okay. Now let's do one more example together. Here is a function, a rational function. Let's first see if I have any holes. Well, I can't factor this, which means that there's no way to cancel any common factors, so there are going to be no holes in this one. But if you look at it, you will see for the asymptotes, the degree of my numerator is exactly 1 bigger than the degree of my denominator. That screams slant asymptote or an oblique asymptote. To find this, we have to do polynomial long division. So we put x minus 1 on the outside and x squared on the inside. What multiplies to x to get x squared? And the answer is x. So we put an x up here. X times x is x squared. X times negative 1 is negative x. I'm going to take these values and subtract them from x squared. So x squared minus x squared gives me 0. And then I can put a 0x here if I want. 0x minus negative x gives me a positive x. So what multiplies by x to get x? And the answer is 1. So 1 times x gives me x. 1 times negative 1 gives me negative 1. And then again, I'm going to subtract this from x. So x minus x gives me 0. And then again, 0 minus -1 gives me a +1. What multiplies to x to get 1? And the answer is nothing. This is my remainder. And again, a remainder is not important when we're dealing with a slant asymptote. This is my slant asymptote. So I have an asymptote at y equals x plus 1. I want to plot this. Remember, when we're plotting lines, we are looking for the slope and the y-intercept. This is in the form y equals mx plus b. B is the y-intercept. In this case, b is 1. So we're going to plot a point here. The slope is 1, so we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And this is my oblique asymptote. Okay. I also have a vertical asymptote. My denominator equals 0 when x is 1. So I have a vertical asymptote at x equals 1, which is this line right here. So this graph's obviously going to look a little funky because I have an oblique asymptote or a slant asymptote. I don't have any vertical asymptotes because my degree of my numerator is bigger than the degree of my denominator. So x-intercepts. X-intercepts are found by setting y equal to 0. So 0 equals x squared over x minus 1. I multiply both sides by x minus 1, and I'm left with 0 equals x squared. So I have an x-intercept at 0, 0, which is this point right here at the origin. I have a y-intercept at f of 0, which is 0 squared over 0 minus 1, which is the point 0, 0. Again, that makes sense because the point 0, 0 is both an x and y intercept. Now, I only have one point because they're the same point. I know in this little area, I have this one point, so I'm going to assume that I follow my asymptotes. So I'm going to follow this asymptote right here, and this asymptote down here, and I get a weird looking graph. But that is to the left of the vertical asymptote. There has to be something to the right of the vertical asymptote as well. So let's plot another point. Let's plot the value of 2. Let's find f of 2. So it means I have 2 squared over 2 minus 1, which is 4. So I have a point 2, 4, which is that point right there. And now I have a point up here. I can go ahead and follow the asymptotes like so. And that is my rational function. So in conclusion, we are looking for holes, asymptotes, x-intercepts, y-intercepts, and then any other point that we need to get a better image of our graph or of our function. All right, I hope you learned some, and I'll see you all in class.